Welcome to I Love Apes. If you happen to be taking AP Environmental Science and you're looking for a little help, you've come to the right place. My name is Eric Sampson. I've been teaching this quite a while, and I think I can help you understand some concepts. And today, the concept we're going to look at is the hydrologic cycle. So, buckle your seatbelt, let's go. So the hydrologic cycle, which I'm sure you studied maybe in middle school or elementary school even, is basically the cyclical movement of water from the surface of the earth up in the atmosphere and back. So it consists of several steps. So the first one is evaporation and transpiration. And then as the air moves up, we get condensation in the clouds, which then leads to precipitation, in which it falls out of the clouds. And then we either get runoff or we get infiltration. So let's just walk through this and make sure we understand it really well. So let's start with this. The energy needed to power the water cycle comes entirely from the sun, like so many things on Earth. The energy source is the sun, and what happens is light energy from the sun gets absorbed by the surface. It causes evaporation to occur, and it causes hot air to rise upward, carrying those water molecules with it. So let's look at step one. Step one is evaporation and transpiration. So evaporation is basically when water molecules are heated and become vapor. Let's look at how that happens. So the sun shines down. This light energy from the sun gets absorbed by the surface, and that makes the surface warm. When we make the surface warm, what happens? The water molecules evaporate. So evaporation is just when water molecules are heated and they go from being a liquid to being a vapor, which means they've entered the gas state. Now, another thing that happens is transpiration. So transpiration is basically kind of the same. We sometimes even call it evapotranspiration. It's basically when water is released by vegetation through both photosynthesis and just through basically releasing water, okay? So now, the thing is, though, this hot air is going to tend to move upwards. And the reason is when you heat a gas, it expands, which makes it less dense than the surrounding air, and therefore it's going to be buoyed upwards. All right, and that leads to our next step. The next step is condensation. So condensation is the change of water vapor from a gas state back into a liquid state as little tiny droplets or ice crystals in a cloud. So here's why it happens. As you move upwards, it gets cold. And this is something you really need to get straight in your head. So I've noticed a lot of students, for some reason, they just forget this. All I have to say is this. If you go up to the top of Mount Everest, are you going to see snow or is it going to be bare rock? It's going to be snow up there, right? And that's because it's cold up there. So as you move up in the atmosphere, it gets really cold. Like when you're on a jet, if you're traveling by airplane, it gets really cold. So it's called adiabatic cooling. We'll study it in unit form. But the bottom line is for this unit here, you need to understand as you move upwards, the temperature gets colder. And when the temperature gets colder, what happens is these water molecules that evaporate are going to coalesce back into little tiny droplets or ice crystals in the cloud. And that's what a cloud is. A cloud is just basically a group of water droplets or ice crystals that are formed in the air as a result of cooling down this evaporated water as it moved upwards. Then the next step is precipitation, which I think you know what that is, but let's just talk about it. Precipitation simply means water molecules are going to return to the ground from the clouds as either rain, hail, sleet, or snow, right? They're going to come back down to the ground. So basically, these droplets or ice crystals, at first they're light enough they can be held aloft by just the random movement of air molecules in the atmosphere, but then they get too heavy for that and they come back to the ground, and we call that precipitation. Now, this next step is where I really need you to focus because I think a lot of students, this is not something they're familiar with, and it's a really important idea in apes. So let's start off with runoff versus infiltration. These are the two things that can happen when the water returns to the ground, and it's a huge important topic in this course. So when rain hits the ground, it can do one of two things. It can either move horizontally across the surface of the ground, and when that happens, we call that runoff. So basically, runoff is just water that is like a skier just going straight downhill, okay? Whereas infiltration is water that then moves into the soil. So infiltration is water that's moving downwards with gravity instead of horizontally across the surface, and it's moving into the soil. And this is vitally important for terrestrial ecosystems. So let's just talk about how infiltration occurs. All right, work with me here. I'm kind of proud of my diagram, so let's see if this works for you. It works for me. Okay, so this is supposed to be soil particles, okay? And there's these little pore spaces between them. And these pores right here are filled with air, Okay? Now what happens is a raindrop is going to land on the top of the soil, and gravity is going to start moving it downwards. So what happens is it starts oozing its way between these pores. But if you've ever thrown a water droplet on a piece of glass, you've noticed it tends to stick, so it adheres to it, and so it means that it takes a little bit of time for this to occur. So this is not like it's not like the water droplet falling through the air. When it takes a little bit of time to move into these pores. And eventually, though, gravity will keep pulling it downwards, and we call this infiltration as the water moves downward into the soil. Now, it will leave little small amounts of adhered water molecules in these particles, and that's going to be vital for plants because that's where they get the water they need for photosynthesis. What happens after infiltration occurs? Well, since some of the water is going to adhere to the soil particles, and it's going to do that in what we call the zone of aeration. Now, the zone of aeration is basically the upper part of the soil where the pores have air in them. So between the particles, there is air, and there's tiny little droplets of water that got in there too. And here's why that's important. Plants drown underwater just like you and I would. The cells in a plant's roots, unless it's specifically adapted for growing in water, which most are not, it can't breathe, it can't respire. It needs atmospheric oxygen in gas form in order to respire, the cells in the roots. And so you need this zone of aeration for that to happen, but that zone of aeration also has to have water in it so that plants can engage in photosynthesis. So as I said, this is the water that plants are going to use. Now, some of the water is going to make it down past the zone of aeration and down below that to what we call the zone of saturation. So whereas the zone of aeration, there is air between the soil particles, in the zone of saturation, it is saturated with water, and there's no air there. So plant roots can't grow in this. So the zone of saturation is the part of the soil where all the pore space is filled with water. Well, the boundary between these two is something we call a water table. So above the water table, we have the zone of aeration. There is air between and some water droplets between the particles of soil, but below it, it's all filled with water. And what happens then is if water infiltrates and gets into this zone of saturation, it's going to begin to flow downhill underground. And we call this groundwater. And groundwater moves very slowly. It moves at maybe at most a meter or two a year, sometimes considerably less than that. So there's this slow movement of water down through here. And the way I like to get my students to think of it is if you filled a sponge with water, like a big, one you'd wash your car with, and then you tipped it vertically, you'd notice the water oozes out of it. That's what's happening. So if you think there's underground rivers, which is a common misconception, no, that's not what it is. It's really like water moving through a sponge. An aquifer is a pretty important concept in the hydrologic cycle. So an aquifer is basically an underground body of water that is occupying pore space between soil or rock particles. So basically you have this region of Earth's surface, essentially, just below the surface, that is filled with water. And here's why aquifers are so important to ecosystems. So basically, as this water flows downhill, like we talked in the previous slide, it's eventually going to make its way to the surface as either springs or directly moving into a stream. We call this discharge. And here's why it's important. So there's lots of places where it rains a lot in the winter, let's say, but it doesn't rain at all for maybe 8 months out of the year. But those rivers just keep flowing for 8 months. How is that possible? Why don't they run out of water? Because the water is coming from these aquifers. It's slowly moving out of the aquifers into these streams. So it gets recharged by infiltration, and then it discharges into the stream, and the streams keep flowing, which is really important for aquatic ecosystems. But humans often want to access the water in these aquifers because, farmers need it to water their crops. Humans need it to drink. We need it for industry. So we can put wells into the ground and take water out of these aquifers as well. Runoff is something that we don't like. So runoff occurs when water reaches the ground faster than it can infiltrate into the soil. So let's look at this. I took my diagram from before. This is soil particles, and now I've tipped it a little bit so it's not quite flat. So here's my water drop. It lands on the surface. Now remember, it's going to take a little bit of time for this to infiltrate. So here it is. This water droplet is in the process of infiltrating. But look what happened. Another raindrop landed on top of it before it got a chance to do that. Now this one, when it landed, there was nothing but air underneath it so it could move in. This one lands on it. Hey, these pores are already occupied by water. It can't move in. So if it can't move into the soil, what it's going to do is it's going to move horizontally across the surface of the soil, and that's what we call runoff. So as I said earlier, runoff is generally considered to be a bad thing for ecosystems. It doesn't happen a lot in undisturbed ecosystems. It's really something that is mostly caused by human actions. But let's just take a look at why it's bad and what happens, okay? So runoff happens when the water lands on the ground and it can't infiltrate fast enough, so it's going to run off across the surface. Well, when it does that, it picks up speed, and it's going to drag soil particles. It's going to erode soil particles, pick them up, and carry them downwards. And if you've ever seen a river or a stream, when it's raining hard, you notice they go from being clear to being brown. And that's because all this eroded soil ends up in the stream. Now, we'll see later in the year, this is problematic in a number of ways. One is it just brings too many nutrients into the stream and causes these problems that normal aquatic ecosystems shouldn't have that much nutrients in them, but we'll cover that later. The other thing that really comes up a lot in the AP test is the fact that this water is moving quickly from the air into the stream. So what's going to happen is the streams are going to flood during rain events. And this is really a problem for humans because we tend to live near rivers and streams. Now, vegetation is really important in preventing runoff from occurring. And think about this. If you are walking outside, you don't have an umbrella, it begins to rain. You know what? You can either stand out, you could stand in your yard, or you could go under the trees. And no one has to tell you this. You go under the trees. It still rains on the trees. It just doesn't rain as much, right? So why is that? So what happens is the rain comes down, and the raindrops are going to adhere to the surfaces, just like they adhere to the surfaces of soil particles. They're going to adhere to the branches of the trees and the pine needles or the leaves. So it sticks to them. And as a result, that slows it down. So instead of coming down all at once, it just comes drip, drip, drip. So if you ever stood under a tree in the rain, you do get dripped on, but not as rapidly. Well, that gives the water a chance to infiltrate rather than running off. But a common question we get asked on the AP test is a scenario in which all the trees got chopped down. We call this a clear cut. And you're asked to suggest a mitigation strategy. So if I chop down all these trees, what I expect to happen is this. When it rains, I'm going to get runoff. I'm going to get flooding. What's the easiest mitigation? Mitigation basically means a step you could take to make something better. Like to mitigate something means to modify it for the better. And so the answer is you simply plant trees. So when you plant trees, you're going to reduce the runoff, and you're not going to get the flooding of the stream. Now let's talk about a concept called convection. We're almost done, I promise. So let's go back to convection. So basically, convection is the upward movement of warm air and the downward movement of cold air. And it happens because the Earth's surface is unevenly heated. Parts of it are warmer, parts of it are colder. So where it's warmer, the air rises. Where it's colder, it sinks. Now, this establishes what we call a convection current, where as this air comes down, it's got to go somewhere, but this air is going up. So what happens is the air is going to move towards where it's going up, and then here it's going to move towards where it's going down. You get this circular pattern called a convection current. Now, it's worth noting that at the surface of the Earth, as air is moving from where it's sinking to where it's rising, we notice it as wind. So if you've ever wondered why the wind blows, it simply blows because warm air is rising in one place, cold air is sinking in another one, and it has to move between them. Now, as this warm air rises, remember, it gets cold up here, so it's going to condense and precipitate out. Now, rising air is associated, and this is a really important idea for apes. It comes up a lot, and that is that rising air is associated with low pressure and wet conditions. So basically, think about this. Convection is taking air molecules that were here and moving them out of here and up. Well, if I take air molecules out of your tire, what happens to the pressure of the tire? It goes down. So we would expect, therefore, to have low pressure here. So warm air rises and we end up getting low pressure. So you should associate rising air with low pressure because as I move air upwards, I have less air behind, so the pressure is lower. Now, this is a mantra for my students, and that is rising equals rainy. Okay, so rising air is going to cause condensation and precipitation. So any place we have rising, we have rain. So when we have low pressure, we have rising air, we have rain. Now let's come over here. Now here I have sinking air. So air that was up here is now moving down into this part of the atmosphere. As I add air to it, what happens? Well, think about a tire of your car. If you add air to the tire of your car, what does the pressure do? It increases. So sinking air increases the air pressure by adding air to an area, whereas rising air decreases it by removing air from a given area. And now the thing is, if rising equals runny, sinking equals sunny. And this is going to be our mantra for a lot of the year. So just please remember, rising, rainy, sinking, sunny. Hey, thanks for watching. Listen, if you found this video to be useful at all, I would appreciate if you go ahead and give it a like. If there's something you want to tell me, some kind of feedback or some video you'd like me to make, go ahead and put that in the comment section for me. Be sure to check the description below. I often post the PDF of the document that I use, also practice problems and so on that can help you do better on your AP test. And of course, you know what's coming. More than anything else, what I really need you to do is hit that subscribe button.